Hello, I'm Joshua Ruben. I'm a mechanical engineering major at UWGB. I'm a freshman and I am showcasing my wind turbine project. So this wind turbine was modeled after the Vestas V80. The rough dimensions like the height and the blade length were all taken, but everything I designed myself. So as you can see here, the nacelle can turn on itself, as well as we'll see in a second that the rotor holding the blades can turn, which in a second I'll show you the gears. There's 100-to-1 gear ratio inside this sheet metal part. It's just two planetary gears that are 10-to-1. So every time the blades spin around one full time, little shaft at the end will spin 100 times. You can see the little bar in the back as it rotates much faster. I will have some animations to show this later, but for now let's look at the tower. Just trying to meet all the requirements for extrusions and such. So this one started with a revolve around the axis. Just because the towers are conic shaped, they are wider at the bottom and get thinner as it goes up. And next I extruded a little base on the bottom and cut some holes in it, just to have screws between the different tower sections, because this is the top tower. And next I extruded these little gears out. And finally added some surfaces, the outer and inner, just because painting the metal didn't work so well. So I just added a new surface body and painted that white. And thickened it a little bit so it would not be so glitchy. Here I have the blade. This one was the real problem in the model, but after a while I figured out something that worked pretty well. So I have a series of planes to do a loft. I started with, first of all, just a cylinder extrude, and then I went to the loft later on. Got a nice straight shape going there, but first I added the cylinder to the end. This here will just be a round cap, so I'm going to fillet it. And then I'm going to flex the blade, which gives it its nice curve shape. This was a challenging step, but it got it to work. And I shelled the blade once I was done. Couldn't get any ribs to work inside. I tried, but it wouldn't work. So next we have the ladder. This was mainly an excuse to use the sweep command. Just wait for me to find it. It shrunk down a bit. I also got to use some linear sketch patterns, which were fun. So started with just one sweep, which I could have extruded a cylinder too, would have worked. That's what I did for the little rungs between the ladders, and I patterned it to be much higher. But I had to also cut off the top, and then I made the edges at the very top square just so I could add relations to the front and right plane. Then add a little bar there, I'll show you in a second, that connects at the very top. And just gotta get rid of that, and it makes things transparent. And then you can see here a little bar connecting to the top of the tower that we looked at earlier. Finally, I'm showing my sheet metal part. This hole covers the gears. This is something pretty simple. Just 5 planes and a hole. Started at the top, just made the flat one, and then did the side. I think I mirrored it to the other side, and then I did the bottom, and cut a little hole, and that was about it. Just had a little bit of trouble getting the edges to match, be the perfect distance to fit on, but overall pretty easy part. And that meets all of the requirements for the project. But now I also made some animations I'll show you in just a second. For now, I'm just showing this off. And here's just a basic motion study I did to spin the blades. And here are the animations. They don't show up so nice with the Microsoft Teams recording, but I'll put them in the comments at the end so you can see them in a little more FPS than this. So here I set it to a background and try to make it look to scale. This one here was to zoom in on the gear ratios as they turn. Don't know how well you can see it with the bad recording, but like I said, I can attach the 30 FPS ones at the end. This one turned out really well. If you follow my mouse, you can see a little gear turning on the inside. That's just how the nacelle works. And that's about it. Thank you for listening.